the total load remains same 5000 kg or 50 kilonewton, and for this load which is applied on the bearing, and the bearing that we have selected has a dynamic load carrying capacity of 146 newtons. So for a given bearing, its load carrying capacity, this remains constant. As the radial load it is subjected to this changes, the life would change. You increase the load and this life would reduce. You reduce the load and its life would increase. So for this load, we got the life in revolutions as 24.8 million revolutions. Now, if I want to calculate this life in hours, how will you calculate life in hours? We know that this is rotating at 1000 revolutions per minute. So in 1 hour, it will have 1000 into 60, these many revolutions.
Okay,
Who is speaking there? When the question is asked, nobody is speaking. Shubham? Shubham? Is that Shubham whose mic is on?
अबे पकड़ लो
No.
Will somebody please ask Shubham to mute his mic? So give me the life in hours. Life is 24.8 million revolutions. It is rotating at 1000 RPM. So which means in 1 minute it is having 1000 revolutions, which means in 1 hour it will have 1000 into 60 revolutions. How do you get life in hours? Vaishnavi? Rishabh? Rishabh Verma, Rishabh Chauhan? Rishabh, you are there? No, both Rishabhs are absent. Prajwal? 414. Give me the answer for life. It is 24.8 10 raised to 6 revolutions divided by 1000 revolutions in a minute, or 1000 into 60 revolution in 1 hour. So this is revolutions per hour. And so life in hours is 414.8 hours. So after continuously running for 414 hours, this bearing would fail. So this is its L10 life in hours. Let us solve for the part B, where radial load is given as 5000 kgs. Axial is 1500 kgs. We have to get the equivalent load first. X times Fr plus Y times Fa multiplied by all those service factors. speed, preloading, the rotation, and before that for this bearing 0418, what is X and what is Y? Open the Shivalka design data book. What is the ratio of FA by FR, and so what is E? What is the ratio of FA by FR? Utkarsh? It's 0.3. And for bearing 0418 or for deep groove ball bearing in general, what is the value of E given? E is 0.25 for deep groove ball bearing. E is 0.25, which means our FA by FR is greater than E. And for this condition, what are X and Y given? If FA by FR is greater than E, what is X and what is Y for deep groove ball bearing? This is given on page number 144. X is given as 0.56. Y is 1.6. Okay. Give me all these service conditions. For constant speed, what is the oscillation factor KO? Oscillation factor is 1. For preload, what is Kp? If the bearing is preloaded, which will lead to impact, so this increases the load on the bearing, reduces the life. So for preloaded bearing, what is the value for Kp? Amir? In the range of 1.05 to 1.2. We have to select some value. What do you want to take? Should we go with 1.1? Some value in this range. Now the rotational factor, our problem definition says inner and outer rays, they are rotating in opposite direction. So what is this rotational factor? If they are rotating in opposite direction. Data book says the value of K is 2. Service factor, it is saying it is moderate shock load. So for ball bearing, what is Ks? 2. Reliability factor is not given, so we assume 90% reliable. So this is again 1. And now you will see that this equivalent load will increase because this is 2 and this is 2. Give me Fe. Everything is known. X, Y, Fr, Fa, and likewise all these. factors are also known. Give me the value of Fe. For getting the life in hours, we have life in revolutions and we have number of revolutions per hour. RPM is given as 1000, which means in 1 minute it undergoes 1000 revolutions, which means in 1 hour it will go 60,000 revolutions. So life in hours is total revolutions upon revolutions per hour. Is that okay? So you are getting load as 22880 newtons, right? Yes, this is in kgf. And if the bearing is same, so the value of C, the dynamic load carrying capacity is same. Let us convert this into kilonewtons, because C we know is in 146 kilonewtons. So you convert this also in kilonewtons to 28, assuming when the bearings are rotating in opposite direction, it is not affecting the RPM, but it is affecting the kind of loading. As I told you, these values that are given in the design data book, the dynamic load carrying capacity, the value of C, or all these factors. So in a lab condition, it is assumed that the inner race is rotating and the outer race is fixed. So as the conditions change, the bearing is subjected to heavier loads. So it is like if there is a steady load, the load is minimum. With moderate heavy loads, shock loads, the loading is increasing. So these are all undesirable things. We want only the inner race to rotate and outer race to remain fixed. This is not changing the RPM of the shaft. That remains the same. Have I answered your question, Prajwal? Yeah, so the moment its life changes, the moment this load changes, its life will also change. So you have seen that because of the rotation of the races in the opposite direction, this rotational factor has become 2. So the load will be double of the condition where the inner race is rotating and outer is fixed. So the moment this load increases, the life would reduce. So we again calculate L10 life, C by Fe, whole cube. Give me the value please in million revolutions. Give me the value of L10 life. .26. Others, please check. Is that 259? is 0.26 10 raised to 6 revolutions. As against 43 million revolutions, this is 0.26 revolution, that is because of all these factors. Let us check in life in hours. The shaft is rotating at 1000 rpm. So the life in hours is number of revolutions. These many revolutions upon 1000 revolutions in a minute, and in 60 minutes it is undergoing 60,000 revolutions. So these many revolutions per hour. And so you get the answer of life in hours. So this is as small as 4.33 hours. So this is an extreme condition where with preloading, with outer and inner races both rotating with moderate shock, the life of the same bearing for same amount of radial load with little more axial load, this reduces from, what was the value here in hours, 414 hours to only 4 hours, which means this is going to fail only after 4 hours of continuous operation with this much service conditions. Only within 4 hours this will fail. So this is its L10 life, which means 10% of the bearings, if they are tested under these conditions for this kind of loading, they would fail after 4 hours. But we don't know which 10% bearings, or out of 100 bearings, which 10 bearings would fail. This we don't know. And so we have to design it accordingly. We haven't considered heavy shock load. If the condition is heavy shock load, then the value of Ks becomes 2.5. Should we go for next? If this is clear, should we go for next? Yash? Divakar? Okay. Let us go for next question. A bearing designed for axial flow compressor running at 1000 rpm is to carry a radial load of 2.5 kilonewton and an axial load of 1.5 kilonewton. The service imposes high shock and the bearing is in use for 40 hours per week for 5 years. This is giving us its life. Select a suitable bearing. Select a suitable bearing. If the shaft diameter is 50 mm. We have tried for deep groove ball bearing. We have solved the problem for self-aligning bearing. Let us try angular contact ball bearing. We have to select one particular bearing. We'll see what is the load carrying capacity, and for this shaft diameter whether this fits in, otherwise we'll change. So this is a combined loading, radial plus axial. Let us try. Angular contact ball bearing, and details for this will be available only in PSG design data book. Angular contact. Divakar, how is this different from deep groove ball bearing? Divakar? Divakar, you are there? How is an angular contact ball bearing different from a deep groove ball bearing? Manas? Ujjwal? Ujjwal, you are there?
Yes, ma'am.
How is angular contact ball bearing different from deep groove ball bearing?
Ma'am, the line of contact is at an angle and not perpendicular.
So how is that beneficial?
It takes axial load.
Good. Okay. So let us find out its life first, and then we'll check for its loading. So give me the life in revolutions. For one per week, it is having 40 hours. Per week. In a year, how many weeks? 52 weeks in 1 year. And this is rotating for how many years? As per the problem, this is working for how many years? 5 years. So for 5 years, 52 weeks and 40 hours per week. And in 1 hour, how many revolutions this would be subjected to? How many revolutions in 1 hour? It is 1000 revolutions in a minute. So in 1 hour it is 60,000 revolutions. So this is in hours, this is number of weeks in an year, this is number of years, this is its RPM, and in 1 minute it is subjected to 1000 revolutions. So in 60 minutes it is subjected to 60,000 revolutions. So this is in 1 hour. So in 40 hours it is subjected to 40 into 60,000 revolutions. So this is for 1 week. And in 1 full year, it is subjected to 52 weeks into 40 into 60,000. And in 5 years, this would be its life in revolutions. Give me the value. $624 million. Million revolutions. What next? We have to get the equivalent load. Open PSG design data book for angular contact bearing. Now we have different series are given 72, 73, BG, 32, 33. These are all SKF series. And the meaning of this series and the load carrying capacity, everything is given in the tables. What is the value of FA by FR we are getting here? What is FA by FR? .6. Different value of E is given, varying from 1.14 to 0.86, and all these values of E are definitely less than, value of E is greater than FA by FR. Let us select one particular value. Should we go for E 1.14? Since we don't know which bearing we are selecting, let us assume 72B series, for which E is 1.14, and so FA by FR is less than E. What is X and what is Y? If we are selecting 72B series for E 1.14, what is the value of X and Y? 1 and 0. What does that mean? What do you understand by Y equal to 0? Amir? Amir? Yes, so Y is 0. It means if we are using an angular contact bearing, the effect of axial load is negligible. Yes, so as if there is no axial component. So the total equivalent load is only the radial component. So that is the advantage of using an angular contact ball bearing. So you are neglecting the effect of axial component. And this we have to multiply with the service condition. The service factor says that it is subjected to heavy load. So you get this. Assume 1.5 as the loading condition for heavy load. Multiply it with the heavy load component Ks. Let Ks be 1.5. So what is Fe? Fr into 1.5. This is given on page number 4.2. This load is coming out to be 3.75 kilonewtons. What is the next step? From this load, how do you get the bearing? Yes. Yes, what is the next step? Saurabh, we have to find the value of C, the dynamic load carrying capacity, which will be Fe into L in million revolutions raised to 1 by 3. So this is angular contact bearing. Fe is known, L is known. Give me the value of C. What is the value of C? C, are you getting 3204, 32 kilonewton? In kgf, this is how much? 3204 kgf. So if it is 3, what is 3.2? Yes. 32 kilonewtons. For this value of C, check for the ball bearing. Check for the angular contact ball bearing. Which ball bearing? Three six five zero. And for this 3650, this is which bearing? 7211B. What is the shaft diameter here? Last two digits multiplied by 5. So the shaft diameters come out to be 55. Whereas in our problem, the shaft diameter is 50 mm. So if you go for 50 mm shaft diameter, it is 7210B, for which the load carrying capacity is 2900, which is not sufficient for this. So now there is a conflict between the load carrying capacity and the shaft diameter. So what do we do? For this value of C, the next available value is 3650. Change E. Yes. For which the bearing is 7211B. But then the shaft diameter will become 55. This cannot work with us because we want the shaft diameter to be 50. So if you turn the page and if you go for the 7-3 series, for